Next topic is color of coordination compounds. So if you have seen coordination compounds kept in your laboratory and everywhere else, you'll see that they are always brilliantly colored. Pink, blue, light pink, green, you name it, you will have it in coordination compounds. So what gives this coordination compound such a color? Why are other compounds not showing this color? Why are only transition compounds or coordination compounds showing this color? So the reason for the color of the coordination compounds, how to predict which coordination compound is going to show which color, and how to predict if the color is going to be intense or if it's going to be a light color, all of this we are going to study in our upcoming slides. Now you have seen that different coordination compounds have different colors. If you take a nickel's coordination compound with dimethyl glyoxime, it will be a red colored compound, whereas manganese usually shows pink coloration. Why does this happen? This happens because of difference between the Eg and the T2G levels. The color in the coordination compounds, it arises because of the difference in the energy between the Eg and the T2G levels. Okay, how is this difference now relevant to the color? When we talk about the Eg and the T2G level, this is Eg and this is T2G. Now let's say there is an electron in a T2G level. Upon excitation, this electron will get excited and it will go to a higher energy level, that is the Eg level. For excitation, this h nu is going to correspond to some particular wavelength. That particular wavelength will correspond to the difference, that is the wavelength of the light absorbed will be directly proportional to the difference in energy of Eg and T2G. Basically, the wavelength is not directly proportional, the frequency is actually directly proportional, because as the difference in energy of the Eg and the T2G levels increase, then the frequency of the light absorbed increases, and we know that wavelength is inversely proportional to frequency. So we can say that the wavelength of the light absorbed is inversely proportional to the difference in energy between the Eg and the T2G orbitals. That is, higher the difference between Eg and T2G, higher the frequency of the light has to be absorbed so that the electron can get excited from the Eg to the T2G. For example, if the wavelength of the light absorbed is 535 nanometer, the color of the light absorbed is yellow. If it's 500 nanometer, the color of the light absorbed is bluish green. If it's 475 nanometer, it's blue. 300 nanometer corresponds to the ultraviolet range. The 600 nanometer is red, and the 400 nanometer is again bluish green, because 400 nanometer and 500 nanometer, they are close together. But does that mean that if a wavelength of 539.5 nanometer is absorbed, your complex is going to be yellow colored? No, it does not mean that. The color that you see is not actually the color of the light absorbed. The color which is shown by the coordination compounds is complementary to the color which is absorbed by the coordination compounds. How do you understand? Like, for example, you see this wheel, okay? In this wheel, this violet and indigo. The violet and indigo colors are a little bit separate to identify, are a little bit difficult to separate and identify. So we take them together as B. Then this is G, B, Vib, Georg. So this is Vib, Georg. Now, if the color which is observed by the coordination compounds is violet or indigo, the color which is going to be shown by the coordination compounds is going to be yellow. The complementary color, that is the color exactly opposite to it in the wheel. If the color which is absorbed by the coordination compound is orange, then the color which is going to be shown by your coordination compound is going to be blue. If the color absorbed is green, red color will be shown by the coordination compound. So whatever color is absorbed by the coordination compound, the complementary color is shown by the coordination compound. And how do you understand what is the complementary color? You understand what is the complementary color using this wheel, that is, just make a wheel with 6 divisions and then write Vib Gyor. So the complementary color of yellow is violet, the complementary color of blue is orange, and the complementary color of green is red. So that is how you can predict which coordination complex is going to show which color.